The IMAM RO 57 was a single-seat, twin-engined, cantilevered low-wing monoplane with a classic lattice frame fuselage of welded chromium molybdenum steel tubing, capped with a thin sheet of aluminum alloy. The classic structure in tubes of the fuselage guaranteed lightness, especially in cases like this where there were important openings in the fuselage. And also due to the speed and economy of construction, in fact a pylon could be built in a few hours and could also be repaired just as quickly, unlike a shell fuselage. Furthermore, the steel fatigue behavior of the steel tubes was a guarantee. In fact, the steel tubes were subjected to axial stresses contrary to a shell, which is tangentially stressed and is therefore more easily prey to fatigue problems. Had not achieved the characteristics that we will then see in the alloys that we will see in the period in which pressurized aircraft gained the aviation scene. The designer of the IMAM RO 57, the engineer Galasu, succeeded, precisely for the reasons mentioned, not only choosing the trellis, but managed to make the most of the possibilities offered by this type of structure. In fact, the aircraft had an empty weight of only 3,110 kilograms, which for this type of aircraft is an exceptional result. Fuselage behavior under bending and torsional stress was equal to or superior to Allied aircraft introduced online years later. Excellent behavior of the RO 57 fuselage to bending on the vertical plane, due to aerodynamic loads due to horizontal tails, but also to those in landing. Excellent those for the bending in the horizontal plane, due to the aerodynamic loads on the vertical tail, and torsion due to the eccentricity of the aerodynamic horizontal thrust always on the vertical tail. If we carry out the vertical bending calculation of the truss, using the polygons of the forces, we realize that the RO 57 was more performing than the Whirlwind and the BF 110. For the torsion calculation, considering the diagonals of the sections as hyperstatic unknowns, and using the criterion of the minimum work, we get better values than the P-38 and the Beaufighter, and even not far from the de Havilland Mosquito. Carrying out a check with the isostatic criterion, the calculations are confirmed. As even if I apply Brett formula in the longitudinal sections of the central trunk of the fuselage, the IMAM RO 57 had, with the same engine, better characteristics than all the equal grades, and even stood up to comparison with many of the twin-engine heavy fighters that came later, even if equipped with much more important engines such as the P-38, of which it equaled the climbing qualities. For the study of the chrome molybdenum tube trellis, Galasu studied a structure that employed various configurations for specific areas of the fuselage, depending on the load and stresses. So we can observe, analyzing the fuselage, the presence of Warren, herringbone structure and Pratt beam parts, depending on the bending torsion stresses or buckling as the most important stress in that particular area of the fuselage.